So let's get started. The first topic we'll discuss is what actually is a service model and how does having a service model benefit you and your customers. So, as a business, you have services you provide to your customer. These services are accessed typically via business applications that can take the form of PC or Mac applications. They can be a web based browser tool, or they can be an application that your customer has downloaded to their phone. The thing is, these applications run on the IT infrastructure, which is huge and is far greater than the sum total of your service. And so it's difficult to understand what your slice of that infrastructure actually is, which is important from the perspective of providing support. So, in summary, your customer uses your services that are provided via business applications that are built upon IT infrastructure. So, when something goes wrong, what are the questions that you need to answer to help restore that service to its normal working function? The first one is, what infrastructure belongs to your service? Do you know? Are you able to go into your data center and work on the correct server that impacts your service only? How do you know when your service isn't available? With all of the failures that might occur in a data center over a given day, how many of them actually impacted your service? How can you effectively troubleshoot a problem? How do you know the flow of your service through the infrastructure that it uses? How can I safely make a change? How do I know the impact of one change on another component in my system? And then lastly, how do I let people know about updates and downtime? That is, when I make a change to a system, I need to be able to predict the impact of that change on my service to let my customers know if they'll be experiencing downtime. A service model provides structure to your IT infrastructure so that you can outline the path that your service follows through that infrastructure in providing that service to your customers. It can be simple or complex. It can provide a lot of detail or just enough for specific use cases. But the service model itself provides that clarity that allows you to answer the questions we reviewed. All right, so let's start discussing the approach to building cloud-based service models using tags. So I guess the first question might be, why do we have this approach? The reason is traditional service models have been relying upon traditional rules. You have a server that hosts an application that is presented to the customer, and you can assign a business service to that collection of software applications and align them along infrastructure services like a database layer or an application layer. Cloud services don't follow these traditional rules. For example, databases may not be dependent upon a server. Storage itself may not be dependent on servers. And applications, the running software, may or may not be dependent on a server as well. For example, the Amazon Lambda function allows you to run code as a service. It's a capability provided by Amazon that hides the underlying infrastructure associated with that service. So, what is the problem then? Cloud services don't fit a typical service model structure and need a new approach to be able to help align the service model into something that is usable. Cloud services are typically represented independent of each other. You can have a wide collection of RDS databases and really have no visibility to which service those databases belong. And lastly, it's difficult to combine independent services into a service model if you don't have some kind of guidance of how to actually do that alignment. So how do we resolve this problem? We use tags. That is, that we assign tags to our cloud-based services that help us understand how those services are used in context with the other components that are available to us from Amazon. And the cool thing is, Universal Discovery can discover these tags and has been doing so since our May 2019 release. And with our November 2021 release, we can now use our Enrichment Manager to be able to use those tags as a method of connecting the various components in our cloud to the proper service model structure. What is a tag, you might ask? Well, there's really no difference between a tag and any other attribute you might have in your CMDB, except that the tag is managed in the cloud rather than something that is discovered on your device. A tag is made up of two components. There is the name and the value, and you manage this within the cloud console that you might be using. Once you have placed a tag on a cloud component, when you run Universal Discovery against that component, that tag will be collected and stored on the record inside of your CMDB. And this tag can be used to manage your query results, and it can also be used to direct and control your enrichments. I've met and talked with many of my Universal Discovery customers, and the feedback is always the same. Cloud tags are an invaluable part of identifying, classifying, and utilizing our cloud infrastructure. In the case of today's presentation, I'll show why that rings true. Let's start diving into some of the details then. What I'm showing you here is a business service that contains a collection of common Amazon components that might be found in anybody's use of the AWS Web Services. What I'll be describing is a generic process that you can use to see how these components are related together into a service model. The intent is not to build a service model that is immediately useful for you in this demo, but rather to show you how it is done and then allow you the understanding of how to be able to adjust the process to meet your specific needs. The first step is to understand what is the name of the business service and the infrastructure services you want to actually create, and to have those ready in hand. The next one is to identify the application entry points to the service in each of those locations so that you can place the business service and its specific infrastructure service onto that component as a tag. And then lastly, it's to identify the components used by the application so that you can relate the component to the necessary application. Let's take a look at what this looks like in AWS. What I'm showing you here is a screen capture of the AWS console for EC2 instances, and specifically the ability to manage the tag. So in this particular case, I am giving this tag both the name of the business service that it belongs to, as well as the infrastructure service it belongs to. You can see that the business service name is TravelPlanner and the infrastructure service name is AppTier. The next step is to identify the application entry point, and that would be a specific type of CI. The example in this case are Lambda functions and running software, which both provide the ability to have an application be run on Amazon Cloud. In this case, we've identified which business service and infrastructure service they belong to. We also need to identify the function of the application, which will be used later to help correlate the other components that are related to this particular application. A third process is to understand which components are used as part of the application. So this is a wider set of CI types, not just the Lambda and running software CIs. It can be pretty much any CI type at all. The key is that you enter in the name of the business service and the infrastructure service so that they're properly aligned, and you identify the application to which this component belongs. Now that the data is available inside of the AWS console, we can discover it with Universal Discovery. After you run Universal Discovery, you'll see that there are a collection of new CI types that have been discovered. You can see a couple RDS databases. You can see a couple Lambda functions, a couple servers, some software, and you can also see all of the tags that have been discovered associated with these devices. These are the same values that were typed in the AWS console as I showed you earlier. We're now to the meat of the discussion here. How are these enrichments actually built, and how do they connect and build the service model? So what you're seeing on the left is the actual enrichment that builds the business service and infrastructure service and relates it to either the running software or a Lambda function. I'm showing a little bit of detail there about how that works inside of the enrichment, and then what actually happens after the enrichment is run on that set of data that we had. But a better way to show this is to actually demo this inside of the tool. Okay, what I'm showing you now is the user interface for Universal CMDB, and I have selected the Enrichment Manager. I'm going to create an enrichment that will build the business service and infrastructure service and relate it to the entry point, which is in this case a Lambda function. So let's get started. First, I'll create it and name it. The next thing I'll do is bring in the Lambda function, and as best practice, I want to bring in Lambda functions that are not currently related to an infrastructure service. Therefore, it puts some protections on my enrichment so it just doesn't run forever. So what I'm going to do is relate these two together with the type of relationship that we'll be using. And I'm setting the Lambda function to only look at situations where there are no current relationships. To do that, we use cardinality, and we look for 0 to 0 being the relationships. So this will only show Lambda functions where there is no relationship to an infrastructure service. So if we do a query, you'll see that there are a bunch. Next, we want to add in the fact that the Lambda functions have the proper tags. And to do that, we check to make sure that the tag exists and is not null. So I'll do that for 2 different instances. One for the business service tag and make sure that that tag is not null. And then I'll do another one for the infrastructure service and make sure that tag is not null. Okay. Now when we do the calculation, we should see just 2. All right, so we've built the query. Now what we want to do is with the queried results, actually build the components as part of the enrichment. So what we're going to do is switch into enrichment mode, and we're going to bring an infrastructure service in, and we're going to bring a business service in. We're going to relate these together using the consumer provider link. What that will do now is create a business service, it will create an infrastructure service, and it will create relationships between them. We need to go one more step, and that is actually identify information that makes the business service unique compared to other business services. So in that case, that is the value name, and we're going to use the tags. And so we're going to look at the Lambda function and the tags. And the business name, the name for the business service will be from the business service tag. And I save that. You can see this up here. The name equals the Amazon Lambda function :tag named business service. And then we're going to do the same thing for the infrastructure service. We're going to update its name based on the value of the tag on the Lambda function. And this time, the tag name we're looking for is infraservice. So save that. Done. Okay, so now I can save this enrichment. And what this enrichment will do is build a business service that's related to an infrastructure service that's related to any of the Lambda functions that are not currently related to an infrastructure service. And if I run this, so once it's run, we can take a look at what's gone on there. There were 2 Lambda functions, so let's take a look at what actually was created. So we'll see all the different business services. We see we have a new one now called TravelPlanner. Let's take a look at what's related to that. It looks like there is 1 infrastructure related to that. And that infrastructure service called AppTier has 2 Lambda functions related to it. So we've built the first part of our business application. Returning to the presentation, we see that we've now completed this particular phase. We've created the business application and the infrastructure layer, and we have linked in the 2 Lambda functions. So we'll start working on the next part of it, which is to run the enrichments to link the cloud components to the entry points. Essentially, what you're doing is bringing in the components of the service that are not obviously connected, but you're using a tag to help with that connection. In this case, what we're doing is using another method of managing tags in the enrichments by comparing the results of tags on different CIs. And the CIs where they compare correctly, we can build a relationship between them. You can see on the left the 3 different enrichments that are there, the type of join relationship that we use, and the end result. But again, let's go take a look at an actual demo to see how this works. We're back in the administrative UI for Universal SeemDB. I've selected the Enrichment Manager, and in this example, we're going to connect any RDS database that happens to be related to a Lambda function that is part of the same service. So to start with, we're going to create a new enrichment. And we're going to bring in the Lambda function and the database services from a query perspective. And we're going to establish a join relationship to them that will look at the tags that are on these CI types, and any place where the two CIs have the exact same tags, it will bring those back in the query. So if you see the result here, we have one Lambda function and one database service. And if you recall from the services that I showed you, this is actually the case. So we want to build the situation where these things are connected together. So since we've identified them already, we now move into enrichment mode. And for those CIs that come back in that query, we want to create a relationship between them called the consumer provider. And that's it. So I'm going to save this. Now, so we can just see how this example is going to work. I'm going to flip back to query mode, and I'm going to take a look at the Lambda function we're talking about here. It's one that's called submit expenses. Okay, so I'm now going to run this rule. It will refresh here quickly. This time, I'm going to take a look at the business services again and follow down that path. We had already related the TravelPlanner, so we'll take a look at what's related to that. There's the infrastructure elements, and those infrastructure elements have the Lambda functions, and then the expenses function has that Postgres database now related to it using the consumer provider relationship. So what I just showed you was the Lambda function connecting to a database, an RDS database. There are other functions that are part of this set of enrichments as well, connecting the Lambda function to S3 storage, as well as connecting running software to any cloud service that are out there. The function is the same for all of them. We use the join relationship to identify the CIs that have the same value in their tags and can automatically build the relationships we need between them as a result. So from there, after all of these enrichments have run, I can show you what the actual results are. I'm back in the administrative UI for Universal CMDB. I'm going to bring up my query that represents the model that I'm looking at, and I can show the results of the query. Back in the presentation, I have a little bit more clarity to what you're seeing. So there were a collection of steps that happened here. First, we established the services, and you can see that we created the business service and the infrastructure services. We did that in step one by identifying the business service and the infrastructure service in the tag. We then created links to the entry points, which can be either a Lambda function or running software in our example. And then we connected the cloud components within those services, which are the Postgres database, the S3 bucket, and other RDS databases. And then number 4, discovered results are still connected, even though they're not added by enrichments. And that's what this item here is. We discovered the fact that this running software was hosted on these servers, and so we didn't lose those relationships. They're still there. They're just there as supporting information to the service, not necessarily part of the service itself. Now that you have a service model, in what ways would you expect to benefit from those service models? Let's take a look at what those would be. The first one is a decreased amount of time to resolve problems, or to decrease the mean time to repair. There's a collection of reasons for that. The first one is having to do with being able to have systemic type notification, and pun is intended there. Knowing the problem from the context of your customer and the services they use will help you better understand how to support that particular service and where to communicate when there's a problem. The second benefit is from the use of a feature called impact analysis, which can help you understand that when a component of your service is unavailable, what would the impact be on the rest of the service? You can compare that result to the reality you're seeing to help identify the root cause. And then lastly is an awareness of who is affected. So when you have a problem and you need to communicate to your customers, since you know who is using their service, you know to whom you need to communicate about the problems your service is experiencing. The second benefit is in reducing unplanned downtime. Now, unplanned downtime is a part of the change management process and something that you're always wanting to avoid. When you make a change, you want to make sure that everyone is notified that the change is happening and that any downtime they experience is planned and they're ready for it. To help you be able to reduce unplanned downtime, you can perform those same what-if scenarios to accurately predict the impact you should expect to see by changing a component in the service. You can see where the change will cause components to become unavailable and where the change will cause components to have reduced throughput. And you can communicate that to your user base. The second one is you can understand the full scope of impact before you make a change. So you're very clear on what's going to happen and can prepare your user base to be ready for any downtime that is planned. And lastly, you can identify all the components in a change prior to actually implementing the change so you can properly plan. And a lot of that planning is just simply in communication to your user base so that they're prepared for it. What you don't ever want to happen is that someone is unexpectedly experiencing downtime that you caused and that was not planned. Lastly, services help your communication. IT infrastructure incidents can be correlated with their service quickly, and then you can communicate to the user so they know what's going on. You can keep them updated until their service has been restored. The next one is that changes can be planned entirely and communication is distributed to all the people who are potentially impacted so that they can be prepared and do not view any service disruption as an unplanned change. And because unplanned changes start to become rare because of the service modeling that you have been doing, you'll start to experience increased customer satisfaction.